Alright, ampacity corrections. Ampacity corrections. How do you adjust the wire for the location, specific location you're using? Okay, anytime when you go to 310, 15, B16, it's not more than 3 in raceway, and not more than 86 degree. Okay, so if we have more than 3 wires in a raceway and the temperature is more than 86 degrees or less than 78, then we can adjust. If it's less than 78 degrees because it's colder, okay, we can add more amps on it. If it is hotter than 86 degrees, well, we can put less amps on it. So we have to derate the wire. So all our codes, so when we look up there, are we using the 60 degrees C, 75 degrees C, or 90 degrees C? If our average insulation that we use on a normal day is a THHN, THWN-2. So that's what the wires that we use, the building wires that we use. Those are usually under the 90 degree. We can't load a wire to that 90 degree rating. Let's say a number 12. That's 30 amps. Okay, this number 12 can handle 30 amps, but we can't load it to that. So the code steps in and says, if you notice, it has right next to it and has an asterisk, and in the 14, same thing, and the number 10. Okay, so the code book tells back and says, well, for the small wires, we can only load a 14 to 15 amps, a 12 to 20 amps, and a 10 to 30 amps. Okay, so I'll get to that later. So that's what this means on the 14, the 12, and the 10. Even though the wire can handle 30 amps, we can't load it to that. The maximum is 20. Alright. But the code allows us, when we're doing our corrections and adjustments, we can use the rating of the wire. We can use the rating of the wire. So we got a 30 amp, 12 gauge. I can use this number to do my multiplications. I can use that number to do my multiplications. So now we know where we're going to find our ampacities. We have 2 different codes that we have to do. Is 310, 15, B16. This is our wire amps, our table. Okay, and then it's 310, 15, B2A, and that one is our adjustments. Well, correction factors, I'm sorry. And then we have 310, 15, B3A. And this is our ambient, so this is our adjustments. Okay, so we have our wire ampacities, 310, 15, B16, and these are all tables. These are all tables. And then we have 310, 15, B2A for our correction, and 310, 15, B3A for our adjustments. So this one is for temp, and the adjustments is I've got a conduit, and I got wires inside this conduit. Okay, adjust it. Okay, because earlier on 31015B16 it says not more than 3 current carrying conductors. Well, it's not more than 3 conductors in a raceway. 3 current carrying conductors in a raceway. Okay, so here in this one I have 1, 2, 3. The blue ones would be my white wires. So I got a black and a red with one neutral, and a black with another neutral. Okay, here, when is it a carrying current conductor? When is it not? Okay, if it was in a residential, we really wouldn't care, but we should look into this. Okay. These black and the red go with the neutral. This neutral does not count. Okay, because we're only taking one phase out of our hots, we have to count the neutral. So in this one we have 4 current carrying conductors: a black, white, and a red. We don't have to count this one because the ampacities of this one will cancel out the ampacities of this one, so the neutral shouldn't be carrying any current. But over here, because I'm coming out of here with my hot, and I'm going to my load, and I'm returning back. Okay, so if I got 5 amps here, guess what? I got 5 amps here. But over here is, I got a load, and I have a load. So there to there, there to there, and then this splits off. So if I got 5 amps here and I got 5 amps here, that evens out. I got 0. 5 minus 5 equals 0, so I have nothing on the neutral. So the neutral is not carrying any current, so I don't have to count it. Over here, it is carrying current because whatever's on the hot will be on the neutral. Here, this hot and this hot cancel each other out, so I got 0. We're talking about balancing circuits in the last chapter. This is why we balance it. We're trying to keep that neutral as clean as possible. Okay? So this is why we have to count. What we count, what we don't count. I don't think any of the questions in your homework cover this, but this is why we do it. Okay? I'll talk about reasons. Sometimes we may be using Romex. So we have a Romex. This one only has 2 wires inside of it. It has 3. One's ground, but it only has 2 insulated wires that can carry current and voltage. Nothing goes on the bare. Okay, it might carry voltage for a short period. Boom, breaker trips and the power's off. So we have this. So we don't have more than 2 wires. We don't have more than 3 wires. Okay, this is a 6-3 with ground. It's got 3 insulated conductors with a ground wire. Okay, I only got 3 possibility of 3 current, but this neutral wouldn't count because whatever is on the black and the red, it should cancel out. If it's all balanced, it should cancel out. There should be nothing on the neutral. So the neutral is not carrying any current. So that means I only got 2. I only got 2 current carrying conductors. Alright. So let's say I'm coming off the breaker and I'm going to my load. I'll come back with the neutral. I got 16 amps and my temperature is 106 degrees Fahrenheit. Okay, what size wire do I need? Okay, what size wire do I need? Well, off the top of my head, I can use a 12 gauge wire. I can use a 12 gauge wire. Okay, 16 amps. My number 12 can carry 20 amps, but the code says that wire can handle 30 amps. Okay, so I can't put it on a 15, but I can use a 20. And number 12 can carry 30 amps, THHM. So I can use this number to do it. Now I'm going to go to table 31015B16. And in your book, it's on page 125. If you go all the way to the right, it's figure 811. Go to the right side, it says Fahrenheit. Oh, no, I'm sorry. On the left side it has Fahrenheit. This is a 90-degree wire, 90-degree C wire, 106. So my multiplier is 0.87. I'm going to multiply that by 30. 30 times 0.87 equals 26. So I don't have to do anything to the wire, because this wire can handle 26 amps. I'm only loading up to 16, so I'm fine. This number has to be larger than this number. But if I'm putting it on a 20 amp breaker, this is a branch circuit. So if I'm putting it on this 20 amp breaker, it also has to be a 20. You always remember that. So this number would have been 19. I can't put it on a 20. Why? Because the wire can only handle 19 amps. I can't put it on a 20 amp breaker. So that means that I'd have to upsize my wire. So in this question here, it's fine. Okay, let me go back. And I had the question, I had it earlier. I had two blacks, a red, two blues, and one green. Okay, so let's say this is in that conduit, so this part here, this is black and white. Okay, and then over here, these wires are also handling, say, 20 amps. But I'm just going to worry about these right here. So what we're going to do is, now, if we look at table 31015B3A, which is on page 124 of your book, figure 810, figure 810. So it says 4 to 6 conductors. Earlier I already said I got 1, 2, 3, 4. The 4 current carrying conductors. So now I want to multiply this by 80%. So it comes out to 20.88 amps. Okay, so now I'm at 20, I'm using the 20 amp breaker, I'm okay. If these wires were using 5 amps each, guess what, I could still use that 12 gauge wire. So, in the figure that I showed, this had 5 amps, this had 5 amps, so my loads were balanced out. My loads were balanced out and everything was okay. Okay, so I don't have anything on the neutral, so I don't have to count it. I don't have anything on the neutral, so I don't have to count it. In the code, they change it where it says conduits and raceway. Well, that neutral's not carrying current, then why do I have to count it? The ground's carrying no current. Ground's carrying no voltage. The only time it can carry voltage and current is if there's a short circuit or a ground fault. Boom! It should turn the power off, and you shouldn't have to worry about it because it's only carrying voltage and current for a short period of time for breaker trips. So this is how we use this. We find our ambient temperature. Okay, we go to 31015B2A where we find our correction temperature. Whatever the temperature is in Fahrenheit, you go look at the Fahrenheit. If you look in the code book, it's on the left side, Celsius is on the left. Always remember is, are you using a 90-degree wire, a 75-degree wire, or a 60-degree wire? Okay, so depending on the wire you're using, it's where we're going. So we got a THW. That's a 75-degree wire. We got a TW or a UF. This is a 60-degree wire. Okay. So we have this, and then we have to go to that table. I found this under that 90-degree because it's going to give you 60-degree, 75-degree, and 90-degree. And it's your multiplier for temperature corrections. For a conduit, well, wires in a raceway, whether it's a conduit with a surface, flex, whatever you got. How many are in there? And then we find. It says 4 to 6 is 80%, 7 to 9, 70%, 10 to 20, 50%. So you don't want to have that many wires because now you're cutting the wire, the ampacities into half. So you want to minimize the wires you have. Like I said earlier, how do you correct for voltage drop? Okay, you correct for voltage drop, shorten the distance, lessen the load. Shorten the distance, lessen the load. Okay, how do you take care of this? Well, one is don't put too many wires in the conduit, and then find your easiest route. Obviously, if you're going across a hot attic, there ain't nothing you can do. So you just have to correct it for that hot attic. Alright? So I hope this is helpful. See you on the next video.